Hi, 2 in the morning last night, someone panicked and sent me this question. It's to find the derivative of y equals the cube root of x squared, but using the difference quotient. It's easy to find it the normal way, but with the difference quotient it's challenging. So I'm going to show you how to find the derivative of the cube root of x squared using the difference quotient. So for any of you who forgot what the difference quotient is of finding the derivative, is dy dx as the limit of h goes to 0 of f of x plus h minus f of x over h. And you know, the goal is always to get rid of the h on the bottom, because we know we cannot divide by 0 when we make h go to 0. We cannot divide by 0, so we want to get rid of the h on the bottom. So let's apply this equation here to what we have here. And you know what? I'm just going to divide this page in 2 pages, because I know I'm going to need the room for this one. Yeah, there we go. So dy over dx, or also we call it y prime, would equal here as the limit of h goes to 0 of the function. This is, so it's going to be the cube root of x plus h squared minus f of x, which is this. So we just added h to the x in the function notation there, and that's what the equation should look like. And we have h on the bottom. Now we have to think about what should we do next. Now, when you look at this, you have to relate this equation here to the difference of cubes. A cubed minus b cubed would equal a minus b times a squared plus minus the cube root of x squared, which is the b cubed. So what I'm trying to say to you here, we converted this here into this equation here. So this is a minus b, so we needed to multiply all of this by a squared plus ab minus b squared. And if we do that, then we end up with this, and that is what that is. So that's what we get from the top. And on the bottom, and of course we don't forget the limit of h goes to 0, and the bottom is going to be the h, and again that part right here, which is the cube root of x plus h squared plus the cube root of x plus h squared times the cube root of x squared minus the cube root of x squared all squared. So that's what we do into the h. Now here we know that when you cube a cube root, the cube root and the cube will cancel. So this and the cube cancels, this cube root and the cube cancels. So what we end up with on top, and we shouldn't forget the limit as h goes to 0. That's supposed to be h go to 0. And that's going to give me x plus h squared minus x squared, as I told you, that the cube will cancel the cube root, and that's why we ended up with that. And then instead of copying the whole bottom, I'm just gonna write this here. So you know I'm gonna come to that later on. And now what I'm gonna do, I'm gonna move to this side right here. Okay. So again, I don't think this line here served us, because this question is a little bit big. So I'm gonna FOIL this, and when you FOIL this, you know you're gonna get the limit as h goes to 0 of This is going to be, if you FOIL it, you're just going to get x squared plus 2h x plus h squared. And then you still have the minus x squared right here. All over that thing repeating. So I'm just not going to copy this to the last step, which equals the x squared here will cancel with the x squared right here. So we have 2hx plus h squared, which we could factor h. So I'm going to factor h, and then I'm going to get 2x plus h right here. Yeah, all over. And I'm going to write that part of the equation right now, that big part of the equation. The cube root of x plus h squared plus, sorry, we should close here, and we have a square right here. So of course we're going to close this, and we have a square right there. And then the cube root of x plus h squared times cube root of x squared minus the cube root of x squared squared. Okay, so that's what I'm doing to all of this. Now the h will cancel with the h, okay? And remember, we always should write as the limit of h goes to 0. Yeah, and maybe I should just do that so you guys know that these steps are one after the other right here. Now I'm going to send h to 0. And when I send h to 0, I'm going to get 2x on the top. And on the bottom, I'm going to get 2x on the top. And on the bottom, I'm going to get, if I'm sending this h to 0, I'm going to get the cube root of x to the 4, because the 2 and the 2 here makes it 4, and since h is 0, plus, also if I send this to 0, then it's going to be cube root of x squared times the cube root of x squared. That's also going to give me the cube root of x to the 4, because we're adding the exponents, that the 2 here is going to be on the x and the 2. And then the last bit as well is going to be, when you square this, the 2 times 2 right there is going to give me the cube root of x to the 4, which in turn gives me 2x all over. These are like terms, so I could add them, and I'm going to get 3, the cube root of x to the 4. And you know what? I'm just going to change that to x to the 4 thirds, because we're going to change it to exponential form so we could reduce here. And I'm just going to take this to the top right here, and I'm going to change the color so you know I am writing the final answer. So I'm just going to write this as 2/3, okay? So again, we're going from here to there. I'm going to write 2/3 x, okay? And the x to the 4/3, I'm just going to move it to the top, and it's going to become x to the negative 4/3. Which is in turn, when you multiply this, x to the 1 times x to the negative 4/3, you're going to add the exponents. So 1 is 3/3, minus 4/3 is going to give me 2/3 x to the negative 1/3, which we should write as a positive exponent. So we're going to get 2/3. We're going to get 2/3, and this x will come to the bottom again. It becomes x to the 1/3. And that's basically your final answer. And we could just write the final answer right here. It's y prime equal 2/3, the cube root of x. And that's your final answer, basically. And you could always double check your answer using the derivative the normal way without using the difference quotient, and that is the answer that you will get right here. Sorry, it's a long question, but I know a lot of students will struggle doing this kind of question. So make sure this is your key right here. And that's what you want to use to get your answer, which is this one or this one. Okay, I hope this helps the person who sent me the message yesterday, 2 in the morning. Anytime, if you have a question, just send it. And when I have time, I'll write the answer and fire it back to you. And hopefully it will help a lot of students that doing first year calculus in university. Don't forget to hit that like button, of course, and subscribe to my channel. Keep on supporting. As always, thanks for watching. Till next time, bye-bye.